These are solutions to Calc 3, Exam 3, the 5 p.m. class. One, y just cannot equal negative x squared, so I draw the parabola y equals negative x squared, a dotted line going down, shading the rest of the xy plane. So it's all the xy plane except for y equaling negative x squared. Number two, if I come along x equals 0, limit as xy approaches 0, 0, I get y squared over y squared, that's 1. If I come along y equals 0, the limit xy approaches 0, 0, 0 over x squared is equal to 0. So I have two different paths with two different limits, therefore the limit does not exist. Number three, fx is 6x squared y squared minus 9x squared y to the fourth. Fy is 4x cubed y minus 12x cubed y cubed. Fxx 12x y squared minus 18x y to the fourth. Fyy 4x cubed minus 36x cubed y squared. Fxy, which is the same as fyx, 12x squared y minus 36x squared y cubed. Number four, z sub x is negative 2x, z sub y is 2y. Plug in 5, 4, negative 9, z sub x is negative 10, z sub y is 8. So plug in z plus y equals negative 10 times x minus 5 plus 8 times y minus 4. I would accept that, or if you can clean it up, 10x minus 8y plus z is equal to 9. Number five, dw dt is a partial of w with respect to x times dx dt plus the partial of w with respect to y dy dt plus the partial of w with respect to z dz dt. And by the way, yeah, w is equal to y e to the x z to the negative 1, if that helps you. So y over z e to the x over z times 2t plus e to the x over z times negative 1 plus negative xy over z squared e to the x over z times 5. Number 6, dy dx is simply negative fx over fy. So negative 3x squared plus 5y over 5x plus 2y, and that's about it. 7, unit vector is negative 3, 4 divided by the square root of negative 3 squared plus 4 squared. That's square root of 25, which is 5. So unit vector is negative 3/5, 4/5. Gradient vector del f is fx, 2 radical y, fy, 2x times 1/2 y to the negative half. That comes up to be 2 radical y, x over radical y. Plug in 2, 9, 2 times 3, and 2 over 3, or 6 comma 2/3. So the directional derivative of f in the direction of u is del f dot u, 6 2/3 dot negative 3/5, 4/5, which is negative 18 over 5 plus 8 over 15, comes out to be negative 46 over 18. Number 8, del f is 1 over y, negative x over y squared, comma 1. And at the point negative 4, 2, negative 1, plug in 1/2, 4 over 4, 1, or 1/2, 1, 1. So the maximum rate of change is the magnitude of this gradient vector, which is radical 1/2 squared plus 1 squared plus 1 squared, which is the square root of 2.25, which is 1.5. The direction is 1/2, 1, 1. You could leave it like that, but if you want to make nice numbers, multiply by 2, 1, 2, 2. Number 9, fx is 2x plus y squared. Fy is 2y plus 2xy, which factors into 2y times 1 plus x. Fxx is 2, Fyy is 2 plus 2x, Fxy is 2y. So the big D is 2 times 2 plus 2x minus 4y squared. Set Fy equal to 0, that means y is equal to 0 or x is negative 1. If x is negative 1, then that means y squared minus 2 is 0, y is plus or minus radical 2. So I have negative 1 comma plus or minus radical 2. If I have y equals 0, then from here, that means x is 0, 0, 0. The big D of 0, 0, plug in 0 here and 0 here, you get 4, which is greater than 0. Fxx is 2, which means I have a min. So f of 0, 0 is 2, which is a min. Okay, and then the big D of negative 1 plus or minus radical 2 comes out to be negative. It's 2 times 2 minus 2, which is 0, minus 4 times 2. That's less than 0, which means I have a saddle point. So f of negative 1 plus or minus radical 2, 1 plus 2 minus 2 plus 2 is 3, saddle point. So f of 0, 0 is 2, that's a minimum. F of negative 1, comma, plus or minus radical 2 is 3. Those are saddle points. Number 10, Lagrange multiplier, del f equals lambda del g. Del f is yz, xz, xy equals lambda 2x, 6y, 4z, that's a 4z. Okay, so that means yz equals 2x lambda, xz equals 6y lambda, xy equals 2z lambda. A very convenient trick is to multiply this one by x, by y, by z. So all of these equal x, y, z, therefore they have to equal each other. So 2x squared lambda equals 6y squared lambda equals 4, it should be a 4z squared lambda, which is true if lambda is 0, or if lambda is not 0, divide by lambda, and you get 2x squared equals 6y squared equals 4z squared, or x squared equals 3y squared, which is equal to 2z squared. Now, if lambda is equal to 0, from these equations, if you look, that means either one of x, y, or z has to be 0. One of them's got to be 0, which means f of x, y, z, if one of these is 0, then that gives me 0, which is neither the maximum nor the minimum, because I'm going to have at least one positive and one negative, as we will see. So that takes care of lambda equals 0. If lambda is not equal to 0, then I have x squared plus x squared plus x squared equals 6, because x squared equals 3y squared equals 2z squared, which means going back to the original, I can call that x squared and I can call that x squared, which basically means 3x squared is 6, x squared is 2, x is plus or minus radical 2, y squared is x squared over 3, which is 2/3, y is plus or minus radical 2/3, z squared is x squared divided by 2, that's 2 divided by 2, which is 1, z is plus or minus 1. So x is plus or minus radical 2, y is plus or minus radical 2/3, z is plus or minus 1. How do I maximize x times y times z? I can make them all positive. So f of radical 2, radical 2/3 1 is 2 over radical 3, or any combination of 2 negatives and 1 positive. And that will give me a positive quantity. I can minimize if I make them all negative. F of negative radical 2, negative radical 2/3, negative 1 is negative 2 over radical 3, or any combination of having 2 positives or 1 negatives. Right, so that was Calc 3, Exam 3 for the 5 o'clock class.